for my IFB102 project, I decided I'll build a time lapse machine. I purchased some clear film canisters and had a stepper motor to start designing the project. I designed the project using free 2D CAD software and printed it out on standard computer paper. I then glued it to MDF and cut out the template on a bandsaw. Once I had finished designing and cutting out all the pieces, I put the frame together and I got it ready to paint. I first coated the MDF in grey primer and then used a white base coat of paint. Once that process was complete, I started on the electronics. I used white LEDs and appropriate resistors and soldered together the ring light. I designed all of the panel images in Photoshop, printed them out on photographic paper and then used a clear coat to bond them to the machine. After the clear coat had dried, it was time to assemble the machine. The next step was to design and solder together a PCB board, which consisted of 2 buttons to rotate the machines on the carousel. This was later controlled by the Raspberry Pi. One of the web cameras which I decided to use was rather large, so to keep the form factor down and the machine small, I decided to take the camera element out of the web camera and mount it to the machine. For the first cycle of seeds, I prepared a range of seeds and placed them on top of a bed of damp cotton wool. The software which I had written assigned a folder to each individual canister, which inside had separate image folders for each camera. The file names were generated by a number which was incremented and saved inside of a text file. Every time the script ran, it meant that the images were compiled to GIF format and they were also in the correct order. The script for the machine was run every hour using crontab. The script took the images, rotated the carousel and saved them to the correct image folder. The local web page was ran by an Apache server and it consisted of a index.html file. This file used images stored inside the image directory and placed them on the page source. This meant that the local web page was updated with the latest GIF files every hour. The script also uploaded the GIF files to Dropbox every hour and that allowed for remote viewing of the progress of the seeds. While the LEDs were not that strong of a light source, it was still enough to ensure that most of the seeds grew in the correct direction. The script also played audio files through the output jack at each stage of the script, which you can hear demonstrated here.
Initiating scanning process. Picture taken. Picture taken. Scanning complete. Converting to GIF format. Local web server updated. Now uploading to Dropbox. Process complete.